Welcome to another filament testing video. This is Overture Super PLA Plus, and it has so great name that I got several requests from my supporters to test this filament. And you know, it is not really cheap to buy USA based filaments here in Europe. And huge thanks to all my Patreon supporters and to the Polymaker who became a channel sponsor, and I even have a budget from them to buy any filament I want to test. On the website they claim that it is ultra tough PLA. This means it resists great to the impacts, and I can test this with 3 different machines. Superior print performance, which is typical for basically all PLA materials, and it is available in 12 colors. The price is $29 per kilogram. The print temperature between 190 and 230 degrees Celsius, and the maximal printing speed is 60 millimeters per second. This is quite low speed. I'm not sure is this all data. I think they should update this, but I'll try to go with a little bit higher speed. Only later I noticed that they have profiles for several printers, so that's why I didn't use them. Latest Bamboo printers are not there, but I checked one for Exxon Carbon. More or less similar values which I will use, except the flow rate instead of 6 cubic millimeters per second, which is correlated to the 60 millimeters per second speed with 0.4 millimeter nozzle, it is 16, 2.5 times more. Now I saw this several times, that the companies add something to their regular PLA and they make it tougher. But with this they sacrifice some other properties, but that's why I'm here, so I will get to test in this video. Cardboard spool, and I can see don't have hardened edges. I can see it's even damaged a little bit, so it cannot go into the AMS it is now. It can go with these rings, just quick check. This is made from the TPU for the AMS. Same print informations on the sticker, and very nice to see this scale. Approximately we can see how much filament we have on the spool. Nice to see they also included the weight of the empty spool. Look at this whitening of the surfaces when it is bended, and this is typical for the ABS filaments, and ABS is very tough material. I'm not sure what material they add to it, but I hope it is not related to the ABS. To get better picture of possibility for this filament, in the results part I will include the data for average PLA calculated from 50 pieces from my summary table. Slicer settings. These are my regular test objects. Only for the impact test I will have more. This is important part for this material. Generic PLA is the start profile, 220 on the nozzle, and the max flow rate from 12 I'm reducing to 8 because I thought 60 millimeters per second is the max speed. But warning, these are not final settings. I will modify them later. Printing will be on P2S. I can feel some unpleasant smell. It is not too strong, but definitely this is not like regular PLA, and I have to ventilate the room after the printing. Oh, looks like there are some problems with bed adhesion. Not sure what happened. But yes, adhesion could be better for the PLA. I'm cleaning the bed with isopropyl alcohol, and I will increase the bed temperature to 65 degrees Celsius. So far I don't want to use the glue stick. It passed that critical point. This is now the 4th layer, but now instead of 2, this will be 2.5 hours printing. Another print I have to stop, warping, more and more similarity with ABS. Adhesion is good, acceptable actually, but because of that warping it reduces. Before the next print, interesting property, we could completely bend it. Actually she wanted to break it and she noticed this. Another attempt, still textured PI sheet, but I used some glue on it and I will add the brim to the printed objects. The printing is at 47% and there is some micro warping, but I hope the glue will hold it this time in the place, and I think it will be okay. I mean, the next step will be to reduce the part cooling if necessary, but I think it will be okay now. I noticed on time the layer adhesion test object removed from the bed and I skipped that object, so the rest will be finished hopefully correctly. Oh. Yes, AI detected the spaghetti, but it's okay. Last object critical, but it looks like it will be finished correctly. Printing is finished and only one failed object I have, but actually it is usable because I can place it in the holder. And nice to see that spaghetti detection worked. And I checked, the bed adhesion is very strong actually. I cannot remove this. Oh, okay, now I can. But this warping means that it is very strong. Not big, but very strong warping because the adhesion is quite good. Another weird thing, few test objects for the impact test I take off quite early and now they are bent in a little bit different direction, some internal stress or something like that, so one of the hardest PLA for the printing. Wow, this should be 80 millimeters. Look at this shrinking. It is bigger than the ABS, which should be around 79.6 or something like that. No wonder it warps. Just for curiosity, I printed this hammerhead on X on carbon and I use engineering plate with the glue on it, and same G-code, same file from the regular PLA. This time the printing was much easier with the Super PLA Plus because it has 50% infill and 5 walls. It is not completely solid inside, and I used the glue. And I printed these test objects from one of the cheapest PLA, and I use completely same G-codes. I'm just curious how much damage we will see if I try to hammer in something into the wood. At the first look, more damage on the Super PLA Plus because it is tougher but looks like not harder, which is resistance of the material to the penetration. But when I was playing a little bit more with these hammers and I had few hits with the edge, there the damage of the Super PLA Plus was smaller. Maybe because of the toughness or maybe because of better layer adhesion, I'm not sure, but anyway, it was interesting testing. Tensile test with horizontally printed objects. I already mentioned that I will include here the result for average PLA, which is calculated from 40 pieces, no fibers PLA. And we can see that this average PLA is stronger by approximately 26% compared to the Super PLA Plus. Layer adhesion with vertically printed specimens. Quite strong. In this test, completely different story. The Super PLA Plus is stronger compared to the average PLA by approximately 24%. And here you can see my rating for this test object, so this means it has a great, almost fantastic layer adhesion. Shear test side by side, horizontally and vertically printed objects. Printed in horizontal position, very similar numbers. Now printed vertically, the Super PLA Plus is much stronger compared to the average PLA, but in this test I have only 10 pieces because I started this type much later. But anyway, this is quite impressive. Look how small is the difference between these two numbers. Torsion test, I'm starting with horizontal printed object. 1.3. Load and 90-degree rotation. And the maximum load. 1.5, the peak. Printed in vertical position. 1.3. The numbers are similar, but huge difference in break types. In both cases the difference is not big, but exactly in direction which is expected. So printed in horizontal position, the loaded 90-degree rotation, average PLA was stronger compared to the Super PLA Plus, but in vertical position where the layer adhesion is important, the Super PLA Plus was better compared to the average PLA. Creep test the deformation under constant load. This is Overture Super PLA Plus, and these two are Voxlab, PLA and PETG. 16.07. Day 5, last day of measuring. 19.75. Let's remove the load. Quite big permanent deformation. On this graph we can see the distance between two reference surfaces. And we can see bigger deformation on the Super PLA Plus compared to the average PLA, but this is only the initial deformation. The creeping is the difference between 2 days. Now I'm already recording first 2 days, and we can see that here the average PLA has bigger creeping compared to the Super PLA Plus, and something similar we can see on the bending test too. 3-point bending test. Distance between supports is 50 millimeters. And I'm measuring the deformation after 1, 30 and 60 seconds under these loads. And currently this is a deformation under 10 kilograms. Just very minimal permanent deformation. We can see bigger deformation on the Super PLA Plus, but look at this under 10 kilograms, it has a smaller additional deformation during this 1 minute compared to the average PLA. Again, similar behavior compared to the ABS. Temperature test in the oven, and this one is the Overture PLA. I want to record the temperature of the first deformation. And no surprises here, approximately at 53 degrees Celsius it started with deformation, which is typical for most of PLA filaments. But I also noticed visually it has a more shrinking compared to the ordinary PLA materials. Over to Super PLA impact test half kilogram hammer. 2, 3. These are 3 edge positions of the hammer in this test. And now the eyes of the impact test on this digital machine. On the right side you can see the result of last 3 measurings. Moving to the Sharpie testing, this is 2 joules hammer. Again with very tough material, no break on the Sharpie testing. 2 joules are not enough, maybe I should replace it with a bigger hammer. Second test. Third. It is quite obvious that this Super PLA Plus is much tougher compared to the average PLA. This is the result from my DIY tester. And interesting, with tougher materials I have bigger difference between DIY and this digital impact tester, but never so big so far. And with the Sharpie, don't forget, no real break even with the 2 joule hammer. I ordered another one which will be equipped with 4 joules. I have this weight, but it is much easier to change the hammer instead to replace the weights. Summary of all results one more time. And as always, this one line will be added to the summary table for my Patreon supporters as my only gift for them. This is the result of the bending test, deformation after 30 seconds, and same bending test but deformation after 1, 30 and 60 seconds, torsion test, temperature test, and the impact tests. Definitely different material from regular PLA, and something what I predicted, it is tougher, but they sacrifice a little bit some other properties, like tensile strength for example. But on the other side, it has still great layer adhesion and some other positive properties. Maybe this head is not the best example for this because it has to be hard too. Maybe actually the handle would be better example for this material. It's still a little bit harder for printing, but it can be printed on open printers too. Actually, printing of this hammer was easier than printing my test objects because it is not completely solid inside, and with this we have a less shrinking and warping, and of course I have to use the glue on the build surface. I checked, this material is tougher than average ABS and it can be printed on open printer, so this can be a big advantage. But don't forget, on the other side this is still PLA with low temperature resistance, and it still creeps. Creeps less than average regular PLA, but creeps more than average ABS. Huge thanks to all my Patreon supporters, because thanks to their donations I can do this kind of works too, and of course to the Polymaker for sponsoring my channel, and to all the other, thank you for watching with this video until the end. If you have some other experience with this material, few lines down in the comment section. Thank you for watching and happy printing!